All right, when you are adding and subtracting rational expressions, it is important to follow steps in order, okay? So with the like denominators, obviously it's simpler than unlike denominators, okay? So we're going to follow these 4 steps in order today. First step we're going to do is write it as a single fraction, because you can do that. When denominators are alike, we can take 2 separate fractions and make them one fraction. It kind of seems like maybe an unnecessary step today, but when we do unlike denominators, it fits in really, really, really well. Okay, so I'm going to do it today with these also. Then the next 3 steps in order: add, factor, reduce. Add, factor, reduce, add, factor, reduce, in that order. That's important to do it in that order. Okay? It doesn't mean you're always going to be able to do all 3 of those steps. Sometimes maybe you can just add and you're done. Maybe you won't be able to add, but you'll be able to factor. Maybe you can't do either of those, but just reduce it. Okay? Sometimes all 3. So ask yourself those things in order, though, after we get it written as a single fraction. Okay? So hopefully you won't find today too impossible. You're going to see a lot of similarities to what you just did on that assessment, because it becomes that. You do a few things and it becomes problems like 5-1. Okay? So, step 1, write this as a single fraction. So my 3x, my denominators are alike, so I don't have to create a common denominator. So I bring over my numerators, 12. It is a subtraction, watch that. And then I bring over my 3. Then I have 3 steps in order that I want to think about. I want to add. Yes, I can take 12 minus 3. I can add that together and get 9. Factor. I can't factor 9. It's a monomial term. Reduce. Yeah, I can do that. 3 goes into itself once. 3 goes into 9 3 times. And I'm left with 3 over 1x, or just 3 over x. And it doesn't make me any difference if you have the 1 or don't have the 1. And then that's my final answer. All right, second example. Write it as a single fraction first. So 18xy minus, again, 11xy over 7. So get it written as a single fraction first. And then 3 steps in order: add, factor, reduce. Can I add or collect those together? Yeah. 18xy minus 11xy is 7xy over 7. Factor if I can, but no, I cannot. And then reduce. Yes, my 7s can cancel. Leaving just xy. All right, next example. Write it as a single fraction. 5x comes over, plus 15. And then my 3 steps in order: add, factor, reduce. So add. No, I can't add 5x plus 15 because one has an x and one doesn't. Factor. Yes, I can take out a common factor of a 5. So this is where it becomes, or starts becoming, just like the assessment you just took. The problems grow, they get bigger. So yes, I can factor. I can take out that common factor of 5 and then reduce. Yep. I got groups that look alike. And I'm left with just my 5. All right, in this next example, I want you, or hopefully you're noticing that that denominator is factorable. We're going to make that step one, okay? They're not always going to be factorable, but if they are, please do it. That's real important for next time, so we're going to do it today too. So x times x, 3 times 3, plus and minus, difference of squares. They're the same denominator, so I don't have to do it twice. I am going to put a little star, actually a big star, next to this question, because this question is commonly missed, and you'll see why here in a second. Okay, so I'm writing it as a single fraction. My denominator's over there. I bring over my 2x minus 18. This is the first one we've done like this. And then we're subtracting a quantity. We're subtracting this. And the other subtraction ones I've done, they were monomial terms, so it didn't matter. But here I'm subtracting a quantity, which means that that minus goes to both of those. So it becomes minus x minus 5. That negative is distributed. If it is helpful, put parentheses around that. And then know that that minus goes to everything in that numerator. And then 3 steps. Add, factor, reduce. So let's add 2x minus x. That's a 1. So this is 2x minus 1x. That's 1x. Minus 18, minus 5, minus 23. Factor, nope. Can't take x minus 23 and do anything to it. Reduce, nope. Can't take x minus 23 and reduce it with anything in the denominator. So you're done. That's your answer. Okay, now I started off by saying we're only going to do like denominators today. So when you look at this question, they're not alike. But I didn't lie, because hopefully, from what we talked about last class, you recognize that these are inverses, so we can make them alike, as long as I take out that negative. So this is what happens. I'm going to make them alike. I'm going to take out that negative. The negative that I have to take out and the minus that's already there become then addition. So the minus and the minus make a plus. So when you take out a negative, it's just going to change the operation between the fractions. So that minus minus, this is going to be now a plus question. So you don't even really have to show me taking out that negative there. You can just change the operation. Addition's always easier than subtraction, so that's great. So my denominator comes over. Bring over the tops. 4x minus 3. Plus is nice, so don't worry about any sign changes. Plus 3x minus 11. And then in order, 3 steps. Add, factor, reduce. Add, factor, reduce. Add, factor, reduce. Let's add first. 4x, 3x, 7x. Minus 3, minus 11, minus 14. So there's add. Factor. Yucky, I can take out a 7. 7 into 7x leaves me x. 7 into 14 is 2. Reduce, yep. I can take out or reduce, cancel my x minus 2's. So that one had all 3. It had add, it had factor, it had reduce. And again, you should see some similarities to what we've already done once we do that addition. Again, I gave you one with not like denominators. I'm not lying, all like denominators today, so we're going to have inverses. We're going to make them alike. We're going to take out that negative, which is just going to change the operation to now a subtraction. So it was an addition, now it becomes a subtraction. So my denominator comes over, not my numerators, x squared minus just the 16, so nothing to carry it through. And then in order, add, factor, reduce. I cannot add those together, x squared and 16, can't add them. Factor them, yes. Difference of squares. I hope that you're looking at a difference of squares and recognizing it that quickly, because we're upwards of factoring over 100 of these by now, easily. Reduce, yep, x minus 4s. Final answer, x plus 4. And then my last one. No inverses, they're the same denominator, so I just got to bring everything over here. I'm going to write it as a single fraction. It's a plus, which is great, because then I don't have to worry about sign changes, everything stays as is. And then in order, add, factor, reduce. So let's add. Our x squareds, 1x squared and 2x squared give me 3x squared. (3x) minus 13x gives me minus 10x. And then minus 8 has nothing to be put with. So bring it down. Or over, whatever. So we added. And now we're going to factor. When we go to factor this, what are we likely, not 100%, but what are we likely to have in the numerator? When we look at the denominator, because we're probably going to be able to cancel, so the numerator is probably going to have a what? And x minus 4. It's likely to have that group x minus 4. So when you go to factor, you can use that helping hint. Trial and error. First term is 3x squared, only choice 3x and 1x. Minus last term means one of each sign. And for 8, I'm going to go 4 and 2. But I'm going to put the 4 second to make it look like the denominator. I don't know if I'm right, but I'm going to check if I'm right. I don't know why I wrote a squared there, sorry. You might be wondering that too. So when I check this, outer times outer, negative 12. 3 times negative 4. Inner, 2 times 1 is 2. Negative 12, positive 2, gives me my negative 10. So that's what I meant by use that as a help. And then reduce, sure. I can take my x minus 4s and cancel. And be left with 3x plus 2. Okay, question 2 or more.